Welcome. Here we're going to look at z-scores, what they mean, and how to calculate them. So a z-score is the number of standard deviations above or below the mean. A positive z-score means the value is larger than the mean. A negative z-score means the value is smaller than the mean. And a zero z-score means the value is exactly the mean. So let's dig into this a little bit. Let's consider an example. Let's say I have the heights of adult males. The mean is 70 inches, and the standard deviation is 4 inches. So we do want to start getting used to this notation. So the mean will be represented here as this x with a bar over it. Sometimes I literally call it x bar. And the standard deviation will be represented with a lowercase s. So if you see x bar and if you see s, you know that means mean and standard deviation. So let's consider just in words a question. The question of what height is 2 standard deviations above the mean. So I would take my mean, which is 70 inches, and I would add the standard deviation twice. So I would have 70 plus 4 plus 4. This will be 78. Now, because multiplication can be represented as, repeated addition can be represented as multiplication, I could also write this as 70 plus 2 times 4, which is 78. So this sentence is the English language description of a question that involves the z-score. So if I were using instead the mathematical terminology, the z-score terminology, I would say, what height has a z-score equal to 2? And that's the same thing. So this is my question. Let me just make a note here. So this is a formula we can use. The value of interest is equal to the mean plus the z-score times the standard deviation. If I'm writing that in with letters instead of words, as kind of our mathematical language, this will be x equals x bar plus z times s. And that's the same thing. That's the question that's being asked. This is a formula that you should know and remember, because you will be asked to, given a z-score, you will be asked to pull the value that is associated with that z-score. Now, I said that a z-score could be positive or negative. So let's do here with this same example, a negative z-score. So let's consider part B. Let's say what height has a z-score of, I'll just say a z-score equal, and I apologize. Let me just erase this because as we move forward, we're just going to start saying z equals negative 1.5. So I would like to use my formula for this. The height of interest, the value of interest will be x equals the mean. So I'll write the formula here, x bar plus z times s. For my particular problem, x bar, the mean is 70, plus the z-score. Now, the z-score is negative. This is very important. If you have a negative z-score, you need to bring that negative and put it into your formula. Okay, so I have negative 1.5 times my standard deviation, which was 4. So this will be x equals 70 plus negative 1.5 times 4 is negative 6. If you're comfortable taking this negative out of these parentheses and just saying that it's 70 minus 6, that's great. If you plug this second line directly into your calculator will just do it. It will do order of operations, so it will evaluate the multiplication, the negative 1.5 times 4 first, and then it will subtract that from the 70. And you'll end up with the correct answer. So be aware that you have that option, especially if there's a calculator easily at your disposal. So x would be 64 inches. That would be the height associated with a z-score of negative 1.5. So that's if we are given the z-score and we would like to find an associated value. In this instance, it's heights. So many things have a normal distribution, and I apologize, I should have mentioned that at the beginning. Z-scores are associated with normal distributions specifically. If your distribution is not normal, well, I guess you could still use the z-score. It's just, I don't usually see them in other situations. So mostly this is going to be associated with our normal distributions. So here's how, if you were given the z-score, how to find the value that's associated. But you can also be asked to do the reverse. We can be given a value and be asked to find the associated z-score. So let's look at what that looks like. We will consider another example. I have this example in the textbook. We have the birth weights of infants. The average birth weight is 7 pounds, and the standard deviation is 0.8 pounds. So here is our data. You will almost always be given both the average or the mean as well as the standard deviation in the problem statement. And then the question is, what z-score is associated with 9 pounds? So the question we need to answer is, how many standard deviations away from the mean is the number 9? So the way that we do this, again, is we have a formula. And the z-score is equal to the data value, so my particular item of interest, minus the mean, divided by the standard deviation. If I wanted to write this using my mathematical notations, z equals x minus x bar over s. So I'm going to proceed with this example. I am looking for the value of interest here is 9 pounds, And I know my mean and I know my standard deviation. So at this point is what we refer to as plug and chug. I'll put all the values into my formula and then I will get an answer. So I will have 9 minus 7 divided by 0.8. You can plug this into your calculator. If you do so, you need to put the numerator, this 9 minus 7, into parentheses. Because if you do not, it will do the order of operations incorrectly. So you need to tell it with parentheses that you want the subtraction to be evaluated first, and then you want the division to be evaluated. So this will be 2 divided by 0.8, which happens to be 2.5. That is the z-score for 9 pounds, 2.5. So it is 2.5 standard deviations above the mean. I know it's above the mean for 2 reasons. The first is that my value is larger than the mean. So logically, I know my z-score should be positive. And then my formula worked out so that the 2.5 is exactly positive. And so I know I'm happy because it should be when my value is larger than the mean. Let's consider another example. How about the z-score for 6 pounds? I'll do the same formula. Z is equal to 6 minus 7, 7 is my mean, divided by my standard deviation, which is 0.8. This will give me -1. Oh, I should have put the numerator in parentheses. I apologize. This will give me -1 divided by 0.8. It is important the order that you do the values in the numerator. The data value of interest has to be first, and the mean has to be second. If you do not put the data value of interest first, you won't get the proper positive or negative z-score that you need. So be very careful. It matters what order you subtract them in because your numerator needs to be negative if the data value of interest is smaller than the mean. So that really matters. Okay, so -1 divided by 0.8 is -1.25. It is negative because the value of interest, 6 pounds, is smaller than the mean, which is 7 pounds. So I'm happy because I have a negative z-score. So that is how we switch back and forth between if you're given a z-score, how to find the value associated with it, which is what we did in the first example. And then if you're given a value of interest, how to find the associated z-score. So that is how we do those two processes. Thank you so much for watching. Let me know if you have any questions.